Okay, the multiple choice questions. So first one, if 50 is an answer to tan, to get another one, you add it on to 180, so you get 230. The second multiple choice one, you can see that on your picture, the y-intercept is 2, the roots are -1, -1, and 2, and the shape's a negative. It would start on the top, one to the bottom, so it's minus x cubed. So when you look at all the options, the only one that works is the one that looks like this. And then if you look at the last one, the 2 minus x, when you expand that, that's going to give you the minus x cubed, so that's the one we want. Okay, number 3, ln 1 over k. Well, you can do this two ways. You can either write it as k to the -1, bring the power to the front, so it's minus ln k, or do the division rule, so ln 1 minus ln k, and ln 1 is 0, so you just get minus k ln k either way. Coefficient of x squared, so that means I want 5c2. I want 2 of these, so 2 squared, so therefore 3 of these, so minus 3 cubed. Remember the brackets, and when you type in your calculator, you get minus 1080. And the last one, area of sector, well, the formula is a half r squared theta. Sub your numbers in, type in the calculator, 7.2. Easy as that. Okay, question 6. Tells you in the question that f of 4 is 0, so that means that x minus 4 must be a factor. And if not a factor, you can divide using the grid method to get what the quadratic factor is. So I've got my x minus 4, my 2x squared equal to 5x minus 12, factorize the quadratic, and we get x minus 4, 2x plus 3. And we're trying to show there's only 2 distinct roots. Well, the roots are 4, 4, minus 3 over 2, so only 2 distinct roots. Part B, we're told to use the sketch to deduce how many solutions there are to that equation. Well, the first thing to notice is that originally there's 48, here's 46. So to get from my original one, I need to move it down by 2. So if I move it down by 2, this pink line here is going to be my new x-axis. So you can see it crosses that line at 3 different places. So there's 3 real roots, because there's 3 intersections. And C, we know that f of x plus k passes through the origin. So that means if I move this, because x plus k is a translation of minus k in the x direction, so if I move it minus 4, it'll get there. If I move it plus 3 over 2, it'll get there. So I get either minus k, because it's a translation of minus k, it's either minus k is 3 over 2, so k is minus 3 over 2, or minus k is minus 4, so k is just 4. That one was a tricky one. 7. This will look really easy once done some more trig with cos, sec, and cot. These stuff will be nice. So I'll show that question. So first thing to spot, it's tan. Tan is sine over cos. So sub it in. So sine x times sine x over cos x gives us 2 sine x squared over cos x times it by the cos x. So you get 2 sine squared x equals cos squared x plus 5 cos x. Now we want everything in terms of coses, so sine squared we can write as 1 minus cos squared. So then times by 2, we get something that looks like quadratic, so then rearrange it, and we get the quadratic given to us in the question. For the second part, you should spot that these two equations are virtually the same. The only difference is x is 2 theta. So straight away we'll make a substitution, x equals 2 theta. So our range is going to change to 0 and 360. And now it's got the same equation as before. Well, we've just shown that that equation is the same as the quadratic one. So all we're going to solve is that quadratic one now. So use your calculator. With y is cos x, so we get quadratic, 2 answers, a third and minus 2. Sub back in what y was, so it's cos x. So cos x is a third, or cos x is minus 2. Well, this last one makes no sense. It has to be bigger than minus 1. So only one thing to solve, cos x is a third. So do inverse cos of a third to get your first answer. Take away from 360 to get your second answer. So there are our answers for x, but we want theta. So theta was x over 2. So divide both answers by 2 to get 35.3 and 144.7. Now this was the same question that I'd given you at the start of this week, so it should look familiar. And then the last one. We had this set up, we had this equation, we knew that there was a minimum here at K, and we wanted to show that the area was that. Well, straight away, as soon as it says minimum, you should realize that that means stationary point, and stationary point means dy by dx is 0. So differentiate it, make it equal 0, and get 2 answers, 5 over 3 and 4. Now you can spot that k here was the second stationary point, so this one must be the bigger number, so that must be 4. And this one here, this maximum, that point must be 5 over 3, but we don't need that. If you want to double check, you can work out the second derivative. 12x take away 34, and if it's a minimum, that should be bigger than 0. So if we solve that inequality, we get that x should be bigger than 34 12. Well, 4 is the only that works for that, so x must be 4 here. Okay, so once we know what k is, we can then just integrate to get the area. So integrate from 0 and 4. We can't use our calculator because the question says, just double check what the question says. It says right at the top block, you must show detailed reasoning. So that means using algebra. So integrate it between 0 and 4. Sub in 4, sub in 0, take them away, and you get 256 over 3.